All right. Good morning, good afternoon, good evening, everyone. Thank you for joining us for this edition of the MuleSoft online meetup. With me today, we have Stephen Yu, who will be talking through runtime fabric upgrades. I know there's been a lot of interest in this meetup, so thank you very much for joining us live. And if you're catching the recording, I hope this is worth your while. If you are joining us live right now, if you could introduce yourself in the chat, maybe mention your name and where you're joining in from, and maybe your employer as well. That would be fantastic. We are taking questions today, but we're using a new format for the questions. So you'll see a link on the slide at the top of the slide. You could use that to ask your question, and Stephen and I will be going through the questions at the end of the session. I've also popped a link to that in the chat right now. As always, we love to read your feedback about these meetups. So if I could kindly request you to fill in the feedback form when you get it in about an hour and a half, that would be fantastic. And yeah, I think that's it for announcements for this time around. Stephen, when you're ready, you may take it away.
Thanks, Justin. Hello, everyone, and thanks for your time joining this session. I'm Stephen Yu. I'm going to walk you through how to run a smooth RTF upgrade today. And without any further ado, let's get started. So first is our safe hub statement for you to read. And then a little bit about myself. I'm Stephen Yu. I'm a senior customer architecture working in MuleSoft for 3 years. I have a cloud background. I have DevOps and consultant background. I used to help many customers migrating to the AWS and build the CI/CD pipeline. My specialty is cloud, especially AWS. I'm a certified AWS professional and specialty. I also have the Kubernetes certification and also the Mule certified developer. My work in the MuleSoft was mainly on the platform side. I used to help customers design the connectivity and troubleshooting connectivity issues, VPN issues. Now is mostly helping customers being successful in the RTF, troubleshooting the issues in the RTF. So RTF is a new product in the MuleSoft. Is leverage the cutting edge technologies, the Kubernetes. It containerized applications and platform built on top of Kubernetes. It's like a small scale cloud for the APIs. It embraces a lot of flexibilities, but the challenging bit is upgrade, because this is a new product. We are keep inventing, adding new features, and also Kubernetes itself is fast moving technologies. So we moved from 1.1 to 1.7 from beginning of this year up until now. And looks we are going to release 2.0 by end of 2020 or early 21. And secondly, we see many new features and coming up in the Kubernetes world and many updates. So there are many upgrades involved in these areas, and we see as a challenging area for the customers. And today we are going to talk about what upgrades involved and how we go through these issues. So here's agenda for today. So we will introduce a high-level RTF architecture and the different layers of RTF. And depending on the layers, we have 3 upgrades in RTF. And we talk about what these three upgrades are and what is involved. And the most challenging part in the RTF upgrade is the appliance upgrade. So our focus today will be the appliance upgrade. We talk about appliance upgrade, how to troubleshooting appliance upgrade, give some guidance and share some documents. And the fourth topic is about RTF backup and restore. RTF backup and restore is not a widely used features, but with this feature, we can incorporate it with the RTF upgrades and to make our life easier in the appliance upgrade, not that stressful during the upgrade. And then we recap, and at the end of the session, we will open Q&A. And you can see on top of this slide, there's a URL. I'll also put in the chat. You can post your questions, and we will go through after the introduction.
Sorry to interrupt you there. I just wanted to confirm that the Q&A feature is allowing questions from people outside of the organization as well. Is that correct?
Yes.
Okay.
Yes, I did.
That's all right. I haven't seen any questions yet. That's why.
Anyone.
Thank you. Let me continue.
Thank you. So next, RTF runtime fabric architecture. So let's check from top to bottom. RTF itself is a platform to run the APIs, Mule applications. So the top layer is about Mule applications. So the applications is containerized. So why we containerize the applications? It's lightweight. It's run in a consistent runtime environment. It can run anywhere. It's isolated. We got all these benefits for the containerized applications. It's a very hot topic in the industry. Yeah, to support running all these applications. On top one is Mule applications. To support running all these applications, we need a Kubernetes environment. But in addition to Kubernetes environment, we also need a component to manage and monitoring these applications. So the first layer, we call it RTF runtime. We need, in these layers, we have components to do the management jobs. Management means deployment, monitoring, and logging, etc. We have many components running in this layer. If you got a chance access to your RTF cluster and check the components, catch report running in the RTF namespace, we'll see all these components. Like, for example, and the 8.1. 8.1 is the most critical one, and this component maintains the connection to the control plane. Once you do the operation in the control plane, it sends a message to a queue, and agent gets this message from the queue and executes these operations. The ingress is to expose the API to external. It's like internal load balancer. Class status is checking the class status. Resource cache is caching the application artifacts. Class IP is doing the Mule clustering service, log folder, 14 logs, etc., etc. And all the components, we call it RTF runtime. And then we go to the Kubernetes layers. And these layers, we got Kubernetes environment and components and some basic services. We got Kube API, Kubernetes, control managers, Kube schedulers, monitorings, and all these things. And also we got basic services like DNS and Helm. Helm is important. Helm is a software management tool in Kubernetes. And with Helm, we manage the components in the RTF runtime layer. So this second layer. And then the third layer is the gravity layers. To establish a Kubernetes environment, we need many low-level services like etcd, like Flannel, like DNS, like all these services. So we put these services, low-level services, in the gravity layer, and this is the third layer. So how we implement this, right? To run application in a Kubernetes environment is pleasant, but it wouldn't be very pleasant to create such an environment from scratch. I mean, the Kubernetes components, it has many components involved and many dependencies. So like we saw the containerized application, we put application in a consistent container environment for applications. We can go further. We use a big container called Planet. And this big container has all these consistency, has all these components inside it. So it keeps a consistent bubble. We don't need to worry there's a difference from different infrastructure. Once we install the Planet containers, it has all these components. This is a big container. So this planning contains services in the low level. We call it garage layers, and has a Kubernetes services, and also based on the Kubernetes services, we have some basic services like monitoring. I mean, the monitoring here is monitoring in the open center. Also monitoring on top of in the RTF runtime as endpoint monitoring. The different monitoring features. We got DNS. DNS is service discovery. Helm to support the upgrade the RTF runtime environment. And with RTF runtime environment, we support the applications. So from top to the bottom, and to bottom to top, right? We got different layers. And the lowest layer is planning container. And this planning container contains all the low-level services to establish the Kubernetes. And then we have Kubernetes layer. This layer has Kubernetes environment and also have some basic components like monitoring, DNS, Helm. And on top of this Kubernetes layers, we have a RTF runtime environment. And this environment we have components to support management and the Mule application. This is different layers about RTF. Okay, so next. So in the RTF, it's not like Cloud Hub. It's not like the fully on-premise runtime. It's a hybrid structure. In the RTF, we need to understand it's a shared responsibility model. I put this link here. We've got documents. So in the RTF, the infrastructure is responsible for, but is responsible by the customers. So customer need to be responsible for the infrastructure, the lowest layer. Then customer need to design the Mule applications, so the Mule application layers. And we are responsible for the middle layers, including the Mule runtime, the RTF agents, appliance itself. So these three things and represents different layers here. The Mule runtime is on application on the top on application. And RTF agents is the components in the RTF runtime, and appliance itself contains the low-level services and also Kubernetes services and the basic Kubernetes service, basic Kubernetes components. So the appliance includes the bottom two layers. The RTF agent contains the RTF runtime layers, and the Mule runtime is on top of all this is for the Mule applications. Right, so in the RTF upgrade, it's the upgrade actually involves three different components. The first is about Mule runtime. So Mule runtime upgrade is simple one. On each application, you can select different runtime version or the different runtime. Just select it and click the button, deploy. It will do the rolling upgrade. So it creates new ports, and once port is ready, it's queue the old ports. It's a seamless process. And this one is the simplest one. Then we have the RTF agent upgrade. RTF agent upgrade, where you click in the endpoint platform, click RTF, click that RTF. In that page, if the RTF agent is available, and the latest version is 176 now, available, you will see a button, and click on that button. What it does in the back is it uses Helm to upgrade all these components in the RTF runtime, including the agents, resource cache, and all these things. And most of these components are upgraded in a rolling fashion. That means it's creating a new one, and once the new one is ready, and then queue the old one. During this process, you can't deploy the applications. It might take a couple of minutes, but the application deployment won't be lost. It's still in the queue. So once a new agent come up, we still get a message and do the deployment, continue the deployment. So you will see some interruptions, deployment interruptions during that process. So one thing need to be aware is the ingress upgrade during this. The ingress is listening on the port 443 because it's binding into this port. We can't create new port and replace old one. Actually, it's terminating the old one and then create new one. So if there's heavy traffic coming in during this time, in terminating the old one, it might have some slight interruption to the traffic, but it wouldn't be long. It depending on the health check period. So once the new one coming up, we take over and serve the traffic. So the RTF agent upgrade is separate from the application. Once we upgrade these components RTF namespace, RTF agent, it doesn't impact running applications. The thing is, it still upgrade ingress. Ingress is internal load balancer. It might have interruptions to the incoming request. So we recommend to do this in your quiet time, not like in busy hours to do this. It's not good. In quiet time, it should be seamless. And once it fails, it will go back to the previous versions. In some cases, and because customer has the environment is slow getting the image, right? So the first upgrade, it fails because the downloading takes too much time. It's timeout, it hit timeout. But in that case, you can run this multiple times. It will go back, and then you click the button multiple times. Each time, it will downloading some layers of the image. So after multiple tries, it will have less time to download the image and will meet the timeout and upgrade to the latest version. So this one, two things to be aware is one is the ingress is updated during this process. It might have slight interruption to the incoming calls. And second is if the internet speed is slow, you can try it multiple times. It fails, it will go back. It won't interrupt the running applications. Okay, now, so our focus for today's session is about appliance upgrade. We've got 3 upgrades: runtime upgrade, agent upgrade, and appliance upgrade. Runtime upgrade is this one, it's seamless. And agent upgrade, it has slight interrupt to the incoming calls. You need to be aware, just do it in a quiet time. And appliance upgrade is the most challenging one. So why it's challenging? Because it includes many components during this process. So you can see the appliance actually including all the components in the bottom 2 layers. So I'm not saying it will upgrade all the components in each upgrade. It depends on the gap. So if you apply in the older versions and you upgrade to very new ones, the gap is big and more components are likely to be upgraded. So if you keep upgrading like just every month or every 2 months, the gap not that big. So that will have less components upgrade during this process. In the appliance upgrade, it upgrades Kubernetes layer services and Kubernetes basic services like monitoring, DNS, Helm, and also some low-level components. And the most challenging one is coming from low-level components, especially like LCD and Flannel and these things. Okay. Right. Once appliance new version is available, you will see a link here. So upgrade available. It's appliance version. You click on it, it will redirect you to a command. So you need to run this command on a controller. It's not automatically processed. You need to run this on a controller and schedule a maintenance window to do it, because it might break the service during this process. It has so many components to upgrade, and then some low-level components, once it's break, will break down the whole cluster. So what's behind? So we are going to get to this topic, and I'm going to talk about 3 topics. It firstly is about what appliance upgrade, how it performs in the back scenes. And usually when we see is that we just see this one command. This one command, but what really behind this command? We need to talk about what's really behind the thing, what's going on during this upgrade. Second, we will talk about what to check to do the upgrade, because I know not everyone wants to know the details behind the upgrade. It's so many things involved. What do you really want to do? You just want to make a smooth upgrade. So to make a smooth upgrade, the key is to use the good preparations. So what you need to go through before the upgrade, and there's a checklist. And with all this, there's still chance to run into problem. And in the problem, what we should do, and we will go through the troubleshooting guide, how to troubleshooting the appliance upgrade. All right, so let's see what's behind an upgrade. I put this in the chat. This is a public repo. You can. Yeah. So in this article, it shows what's behind upgrade. And the first part is when we run this RTF appliance upgrade, and what options behind it. It firstly downloads the package from the control plane and unzip it and upload to the Gravity site, and then do the upgrade, and then kick off the upgrade. This is behind the RTF appliance upgrade, this command, and actually holds these operations. So once upgrade is started, we will see the Gravity plane. So Gravity plane is a planning system to break down the upgrade into separate small steps to be executed. So the phase on upgrade perform separate and individual actions to make progress to the upgrade. The planning system creates a plan for the upgrade when the upgrade is triggered, inspecting the current status of the system, and only includes the steps necessary to get close to the latest version. So the steps to be executed, it depends the gap with the current appliance version and to the latest version. There are some common patterns in the upgrade. So once we run the Gravity plan, we will see the phase, right? The phase, it has a parent phase and a subphase. If you want to make a phase name, we use / to connect all these phases like this. If you have some troubleshooting appearance in the upgrade, you will need a phase name to roll back or execute. And this is the way to make the phase name. And also note it first upgrades the low-level components and then upgrades the services on top of Kubernetes. And for the low-level components, as doing in a rolling fashion, it upgrades on each node. So in this node column, you will see the node IP address or node name. That means this phase is executed on that node. So the init, and we will see the status. Status has unstarted, means not started yet. In progress, completed, failed, rollback. Just literally add what it says. In the upgrade, as the normal process, if you use the RTF command, it will do a kickoff upgrade and do an all automatic upgrade. If you want to see the details, you can run these steps manually. And when you kick off the upgrade, you put -n at the end, so you can run a manual upgrade. You will see more details during this process, but this is only for your interest. So this is about the plan and status, and we need to know about the node and also the phase name. How we make up the phase name is important to do the troubleshooting process. So It's got some general patterns. Is in it is to do some legacy, remove some legacy upgrades directories, and update Docker configurations. Do some initialization checks, check some, do some pre-flight checks, and pre-upgrade, pre-update. You can put some customer hooker in it. We don't use any hookers. And Bootstrap. Bootstrap is used to do initial configurations on each node within the cluster to prepare the node for the upgrade. So up to the Bootstrap this phase, there's no impact to the system. The system is not changed yet. It's just do some preparations, do some checks. In some rare cases, you want to, during the upgrade, you want to roll back fully to the previous version. You don't need to roll back all these phases. You can only roll back before, stop before the Bootstrap and reset status, because these two, the phases up to the Bootstrap does not make any change to the system. Then it checks the codiness, if the codiness configurations. And then it goes into the upgrade. Upgrade is for now is upgrades low-level components, and especially the planet. Master and workers group subphase are these need to be upgraded on the planet containers on each node in the cluster. This operates as a rolling upgrade strategy. When one node at a time is cordoned and drained, upgrade to a new version of planet, and restart it, and then go to the next node. Each node is done in sequence. So all the moving software around the cluster, the application cluster layers remains online. That means when doing the rolling upgrade, it's only one node is impacted at a time, not the whole cluster is impacted at a time. So what it does is the first node is important. The node where you started is important. We will get you there. So you need to remember which node you started the upgrade. And this node, first we remove the leadership elections. We know that in the RTF controllers, they got 3 or 5 controllers. Only one node is a controller node. And this node is taking care of the Kubernetes API service, as a service which is critical to the system. So when we upgrade this first node, it first step down the leader election, means this lead is outside the leader. Then we drain the service. The drain is basically the same thing as the kubectl drain and drain command. It's evict the port to other nodes. So during this process, we might, if the RTF component is running on this node, it will be evicted to other nodes. It might be like agent or other different services, so they might have some interruptions. So we remove all these services to other nodes. Then we do the system upgrade. And system upgrade is the phase to upgrade the planning services. Once it's passed, the gravity, when we're on gravity, it will go use a new version, right? Then it's 10. 10 means put some 10 on this node, so not all ports can run on this node. Only these services can tolerate the 10 can run on this node. Why are we doing this here? Because we want to run some critical services first and then let others run. Like in this phase, you can see eternity and cordon, but only these endpoints can go back to this node because we want this endpoint service to run first. Then entity, and then we can all other services can come back to this node. This is general process to upgrade the planet, the low-level services on each node. But the low-level services does not include the SCD. SCD has spatial handling. I'm going to talk about that. So for now, we know the low-level components are upgraded on each node, and this phase, system upgrade phase, is the phase actually doing the upgrade. So once this phase is passed, the upgrade is the gravity will be in the newer versions. And during the troubleshooting process, you might need the gravity, you might need to roll back and execute it again. And one critical thing is you need to use the latest gravity binary, right? So you need to check if that node has passed its phase. If like I'm if like this phase failed here, I want to roll back this phase on this node because this phase is not executed yet, right? I need to download the latest gravity binary to roll back rather than in the old ones. If the phase is like failed here because endpoint this phase, because system upgrade is passed, I just need to run the gravity to use the default gravity to run the rollback command. And there's articles to show you how to download the gravity binary from the gravity side store. But one thing keep in mind is we need to check if the gravity is in the new version or old version, and we need to use the new version to do the upgrade, to do the rollback and execute all these operations. And this is the phase to do the gravity upgrade. So all these low-level services are upgraded per node. So we can see the node appears in each column. So it's going to the master phase and going to each worker nodes. Once it's done, the upgrade will go on top of the Kubernetes layers. So as I said before, and all these low-level components are upgraded in these phases, but LCD is different. LCD is a very complex services to do the upgrade. We can't do it in the routing fashion because sometimes even minor change in LCD version, it doesn't compatible with old LCD version. So if you upgrade LCD in a new version, it can't connect to the old LCD cluster. What do we do the LCD upgrade? Actually, we do a backup and restore. We backup LCD data and shut down LCD and upgrade LCD to a new version and restore LCD data. And this is one of the most difficult phase if you run into issues. But LCD is critical. We use LCD to synchronize the status across the nodes. If LCD got a problem, the status is not synchronized, so whole thing might be messed up. I'll get to that shortly. And in this upgrade, we don't have the LCD, and so it goes to the Kubernetes level. Kubernetes levels got different applications. And you note that on this Kubernetes level services, they don't have the node IP address, no name in it, because it doesn't matter. It's running in the Kubernetes levels. Kubernetes level is a resource pool. So in this phase, if we look into it, you will see it actually creates a port to run the extra upgrade. So if you want to see what's going on, if you see the issues during these phases, on top of upgrade the Kubernetes applications, so we need to check the log for this port, right? See what's going on, what's went wrong, and fix it, and roll back and retry. One troubleshooting technique is if you see the phase fails, and in the low-level components that's still specific to each node, we want to see what fails. We can enable web logging. And to enable web logging, the best place to run this step is on that node rather than on the node you started the upgrade. This is one technique we need to keep in mind. We don't have enough time to go through all these details today, so I'll leave this document here. Just give you some brief ideas how it works behind the scenes, and 3 things need to keep in mind. So first, the upgrade is doing in the low-level component first, and in the Kubernetes level, and in the low-level components, if you want debug, you run rollback and run the phase on each node which fails. If on the Kubernetes, it's upgrading the Kubernetes applications, you can check the port logs, what's going on for that phase. Secondly, the LCD phase is different. I'm going to talk about how to handle failures in LCD. And third, so you need to be aware of the gravity version when you do the rolling back. And the rollback and execute is a main technique. We resolve the issue in the upgrade. When you do this, you need to make sure the gravity in the latest version And if it's not in latest version, you need to download from other nodes. And there's a way you, and this phase is passed where Gravity will in the new version. Otherwise, Gravity is still in the old version. In that case, you need to download the Gravity binaries. Okay, so 3 things in mind. And I will recommend, if you're interested, you can go through these documents after this session, and you can do some tests. You can run this command and use the old version cluster and run this command manually and run many upgrade and to see what's going on in phase. This will have a much more better understanding. So there's so many details involved in the upgrade. I know not everyone is interested. It's not not a simple thing to go through all these things. It takes time. So to make sure your upgrade is as smooth as possible, what you need to do is do a better preparations. Is there a list to go through before you do the upgrade? So what time items to check in the appliance upgrade? Let me put this link in the chat. This is a support article. So there's about like 9 items to check. So number 1, make sure Gravity status is in healthy. And not only the status is active, but all the nodes are healthy. Sometimes we are fixing one issue is the node is showing offline, but the status is active. Right? So upgrade can still proceed, but we have issues. You need to check all status are healthy and all the nodes are online, and then proceed. Upgrade RTF CTL to the latest version. So RTF CTL is a tool to wrap up all the upgrade. We are incorporating some checks into RTF CTL, so to make sure to use the latest version each time. And this is an important thing, and is related to the etcd upgrade. etcd is a key services to synchronize the status. But if you got issues and during the etcd phase, if we resume the upgrade from different node, it will mess up the upgrade. So make a node which controller you start the upgrade and always resume upgrade from that node. And for the latest version upgrade, latest appliance version, we got the checks in it. You can't resume from other nodes. You have to resume from node you started upgrade. But for the previous version, to make a node controller where you started, resume from this one. The fourth one is called kernel accounting memory issue. It's a very low-level issue. It impacts C group creation. It causes some leaks in the system, and it will fail the upgrade. So we ask customer to upgrade to the new kernels and do a reboot before you do the upgrade. And reboot will apply the kernel to the system. The fifth one is use the SS console rather than Open Center. So why we use this? I know many customers, I know many of you might just use Open Center to do the upgrade. If it goes smoothly, it's fine. Because when you first kick off the upgrade, it goes to the background. Once Open Center is restarted or updated, it doesn't matter, it's still going on in the backend. But if it fails in the middle, if you're doing some troubleshooting and resume, this upgrade now in the foreground. If the Open Center is restarted, the upgrade will be interrupted as cause issue. So make sure you use in SS console rather than the Open Center, because Open Center might be upgraded, might be restarted during the process. And this is the sixth item is a special version. And this version has critical issues regarding the teleport. And one symptom of this, as you can't see all the nodes in the Open Center server view. If you can't see all your nodes in this view, it's highly likely you are hitting this issue, and there's an article to fix this issue. Otherwise, the upgrade will remind you to fix this issue to proceed. because we see an upgrade and goes to the Kubernetes levels, it will create some new port to do the extra upgrade jobs. And in that case, and we use some resources, right? We use some resources on each node. So we see sometimes and very rare, and all the resources are fully occupied by the applications. The upgrade does stuck because it don't have enough resource to create some upgrade port to do extra upgrade job. So shut down and stop some application to leave some 20% resource on each workers and make sure the CPU and memory is not fully occupied to make sure upgrade can go smoothly. And this is very real. If the appliance is in a very old version, like 1.02 or earlier versions, the upgrade, the proxy configurations might be lost during the upgrade. So make a note of apply a proxy version and apply afterwards. So last one is we see from a couple of cases, some security software or some configuration management tools is changing the permission of some folder because they think they might be meet the requirement, might not be secure enough, or just remove the user from the system, like remove the planning user from the system. If they do this, the RTF cluster is still running. It's running fine. It won't impact the running RTF cluster. But once you restart the RTF, and this problem is surface, and when it fails, it require the permissions and require all these users. And if you got like you suspect this kind of thing happens in your system, so the best thing to do is reboot your system, reboot RTF nodes before you upgrade. This will surface all this problem. If upgrades fail in the middle, it's usually takes longer time to troubleshooting and fix. So you reboot it, you find this issue and fix before the upgrade, and then do the upgrade. Okay, this is the 9 items need to check for an upgrade. We'll keep updating these articles. If we got other items, we'll keep adding to it. And meanwhile, we also have requesting add more checks to the upgrade. So in the new versions, some may not need to check, but still, and all these items we collect from many cases, and worthwhile to go through this list, and we were improving the product and put more checks in it. Okay, so now we talk about what's the appliance upgrade looks like and what we need to do before an upgrade. The preparation is the key to make a successful upgrade, but still that chance we might see some issues during the upgrade and how we troubleshooting the appliance upgrade. And this is the article for troubleshooting appliance upgrade. So for the troubleshooting, first thing you need make up the face name to roll back and try again. So the main idea of this troubleshooting, and this article looks long, right? But the main ideas of the troubleshooting is roll back and try again. As simple as that. So you need to know what's the face name to roll back. And this is how to do it. You run the gravity plan, you will see the face name and connect all this face name is a slash. This is main ideas of troubleshooting is roll back and try again. Right? It's a lot of problem we fix during this process. Just roll back because first time it might hit some issue and roll back will meet the requirement and resume, just go past that phase. If it doesn't work, how we do that? So we need to see the logs, what's going on, and fix the issue and then proceed. So the hardest thing for the appliance upgrade is because the infrastructure is all different and has different requirements, have different software, different networking, and all these different kinds of things may lead to a failure in the upgrade. We try to test as many as we can, but still there's some scenarios we don't know. And in that case, and if you start, you own the infrastructure, you have more knowledge than us, and you look at these logs, you will figure out what's going on, what's went wrong for the upgrade, and fix that issue. Maybe open a port, maybe change the permission, and then resume it. So if we do the rollback upgrade, as I talked before, you need to use the latest gravity binary. And here's an article to tell you how to download the latest gravity binaries during the RTF upgrade. So you download RTF binary on the node that fails that phase and run it with the debug option, the -debug option to see the purpose logging, and check those logs and see what it tells you. And if you something is obvious, just fix it and resume it. If something really hard to fix it, you can read the support case. And if the upgrade fails in the LCD shutdown phase, this phase will upgrade LCD. LCD is a critical service during upgrade. So how we handle this this problem? So there's a special techniques doing this. The idea is if LCD is failed, the upgrade status is not synchronized across node. And you need rollback. If only one subphase failed in LCD shutdown, you need to roll back all the subphases and then resume. Before you do the resume, you need to make sure the status is synchronized. So one thing is that you usually run the gravity plan in all the upgrade nodes, and this will tweak the synchronize to the node. This will trigger the synchronization to the node where you started upgrade. Then you can resume the upgrade. If it's still not synchronized and you need to manually execute each phase with a --4 flag to make sure this phase is executed. Because if LCD is not shut down, it will fail in the next stage. Because at next stage we upgrade the LCD to a new version and got some conflict, they fail next stage. So make sure this stage is fully executed. So two key things in the LCD shutdown. So first is if any subphase tests in LCD shutdown, you need to roll back all the phases. Secondly, you need to make sure the rollback status is synchronized across node. One thing is to do is gravity plan. We trigger synchronization. If it doesn't work, force to run that phase. Otherwise, we skip that phase, we run into the issue in the next phase. And this article gives you more details how to do that. If the upgrade fails in the Kubernetes application level, you need to check the logs from that port. If it fails in the low level phases, that phase is specific to each node, you need to run that phase on the node that fails and with debug option so you can see more logs. So the idea is simple, right? So we need to roll back and see what's went wrong during the phase, fix the issue and resume. And to roll back it and to see the mobile logging, you probably need to run it with debug option on the node and to see what's going on, to swap logging and to figure out what's going on in that phase for that failures. And for the LCD shutdown, they got some special handling, and let's follow this article and go through this phase. Okay, this is about troubleshooting the appliance upgrade. There's quite a lot of information, I know that, and I put all the link in the slides. You can check all these details later. So now we talk about the backup and restore. So RTF backup and restore. When I talk about backup and restore here in the upgrade, because we can use backup and restore method in the upgrade. When we do the upgrade, we backup and restore to a new cluster and upgrade the current one, because new cluster is running on online serving the request. We don't need to be very stressful if it's running into the issues. But there are pros and cons. If you do this way, there's quite a lot of work to do it. You need new extra hardwares, need a lot of preparations. But the good thing is it gives you more time. It's not that stressful for the upgrade in case it runs into issues. So RTF backup is actually backs up all the resources in the Kubernetes levels. It does not back up the like application packages and all these things, because applications is stored in the Exchange, right? And the image in the ECR repo. So what is backs up? It backs up just Kubernetes resource definitions. We know in the Kubernetes you can create a resource with a YAML file. And what is backs up? It just backs up all these resource definitions in a YAML file and put in this file. So the backup actually very lightweight. It might be maybe a few megs. You can back up your whole RTF cluster. So the idea is in the running cluster, we back it up and take a backup package. Then we create a new cluster and restore it. We disconnect the old cluster. Then we have a new cluster running and serving the traffic. Then we upgrade the old one. So the traffic is coming to the primary cluster. We restore it to a DR cluster. And the traffic can be shared between the primary or DR cluster. Then we go from this one. This is the third one. And then we remove the primary cluster from serving the request, and doing an upgrade on this primary cluster. Then we restore from DR cluster to primary cluster. So the idea is simple. I just gave you an example what I just did in cluster, so you might see more concrete ideas. I create an old. Let's see, my cluster variant is in this version. This is the old version. I create another cluster in this version. So how can I create an old appliance version? You just need to use a sample script and modify the installer URL. For the installer URL, you can get the URL from this knowledge article. I got this. I use this old version. I create a cluster. Then I set it up and deploy my applications. Then I create another cluster. For this cluster, I use same Appliance version, but I made some change in init.sh script. That script is installing the RTF components. Because in this RTF cluster, I don't need RTF components. I want to restore from my primary cluster. Just I comment it out. The 3 lines in the init.sh cluster, excuse me. This way, create a new cluster without pairing up with a control plane. I don't need to give it. There's one important thing is activation data. Activation data is used to pair up with the control plane. So for this backup cluster, I just install it Appliance. I don't install RTF components, so I don't need to put the activation data in it. You see, I don't put activation data in this var file. I create it, then I back up from my primary cluster. I just run RTF-CTL backup. Give me like 1.5. Very small package. This is a small package. Then I disconnect my primary cluster from the control plane. What I'm doing, I just scale down the agent. So agent is a component, is keep communicating with the control plane. I scale it down so it disconnects from the control plane. And then I do the restore. Doing the restore in my new cluster. And this cluster will create all these services, all these resources in my primary cluster. And these resources will download the images, will download application packages from the control plane, and we'll start. It will take a while, maybe 10 or 15 minutes, but it's very light backup restore. I'm restore all the resources, and the heavy part is still in the control plane. So this backup cluster need to have the same connectivity as the primary cluster, because it needs to pull the image, need to download all these application artifacts. So then I go back, then I switch my traffic to my backup cluster. Then I don't have any pressure to upgrade the test cluster because it's not serving any request. So I just take my time to upgrade my primary cluster. Once it's done, I back up again in my backup cluster and restore it back to my primary cluster. Yeah, same thing. So I scale down the backup, I disconnect the backup, and I restore it back, so it will connect to the control plane. And one thing is just this is probably a problem. I have talked to the engineering team to fix it, and this resource is lost in the definition. So there's one extra step here. You need to create this resource manually, but this will be fixed shortly. So to summarize, the backup is backup the Kubernetes definitions and the credentials, and all this thing is used to create the same resources in the backup cluster and pair up with the control plane. So I backup all the definitions. When I restore it, it creates all the Kubernetes resources and use credentials to pair up with the control plane. So when you run the operation in the control plane, and this client will use these certificates, use credentials to get all the command and execute on this cluster. And this cluster goes to your primary cluster, and you take time to upgrade your old cluster, and then doing it reversely and backup the backup cluster and restoring your primary cluster. So in this way, you get more time and less stress in your appliance upgrade, but it definitely takes more time and more effort to do that. This is and the pros and cons. Okay, so we're almost getting 1 hour. To recap today, and we talk about RTF architecture and shared responsibilities. RTF has different layers, and these different layers have 3 upgrades: a runtime upgrade, RTF agent upgrade, and appliance upgrade. Let me talk about the most challenging one as appliance upgrade. In this appliance upgrade, we talk about what's behind the upgrade, what's really happened behind the things, and how we prepare for an upgrade. And if we run into issue, how we are troubleshooting the upgrade issues. At last, we talk about we can incorporate the backup and restore method in our upgrade. So we can restore to a new cluster and upgrade the current one, and then restore it back. So this way, they have more time and less stressful during the upgrade. All right, so this is about pretty much about today, and let's see the questions. That's one thing is you can submit your questions with this URL on top of each slides. Now let's see the questions.
So Stephen, if you go into the presenter view, I think you can see the questions and then present them on screen. Alternatively, you can just read the questions there. I have voted on some of the questions that have not yet been answered. So anything with a thumbs up and a number 1 next to it has not yet been answered.
Yeah, okay, so I can't see continue recent, right? Continue recent. Choose the session. Why I can't see the questions here?
In your own presenter view, can you see the questions? Oh, okay.
Oh yeah, I can see. Okay.
Yeah, perfect.
Okay, first question is Daha. What are your recommendations for upgrade RTF3 upgrades the worker nodes vertically and horizontally in order to receive best performance? And also how much vCPU should be kept in standby mode, something less? Okay, this is not related to the upgrading topic today, but I'm happy to answer this question. So this is more about related to the performance in the applications. So we know the application is running in the worker nodes. The performance for each application is related to the resources, how many resources you allocated to the applications. So one thing we recommend is use the burst mode. You can use small number of CPU reserve and have high number of CPU limit. So the burst mode, it works. The reserve CPU is always guaranteed whenever it's used, and when it requires new more CPU, the system will check if the idle CPU is available. If it's available, this application can be burstable to that amount of CPU. So it had best use of the CPU, the system resource. For the vertical and the horizontal upgrade, it both can help to improve the performance. So vertical means you add more CPU and add more memory to the same node. Maybe have a new generation of CPU. This CPU have high frequency. So even I have same amount of CPU and high frequency CPU is faster than the low frequency one. So add more CPU vertically also helps. If you add more CPU horizontally, you got more resource. You can allocate more resource to each applications. So it also helps to improve the application performance. And then how much vCPU code should be kept in standby mode? It really depends, and depends for the requirement. And one important thing to consider is in the case of one node or two node fails, Kubernetes will schedule the applications to other nodes. If you got enough resource on the other nodes, this port can still be keep up and running on the nodes. If not, this port will be suffering. So it's really depending on your requirement of the whole, to what extent you want to be resilient. So we usually recommend like, let's leave 30%, 20% resources. 30% means in the 3-node mode, if one node is totally totally down, and all these ports can still be scheduled to the remaining 2 nodes. If in a 2-nodes mode, if you want to be fully resilient for one node failures, probably need to 50%. If you got more nodes in the cluster, just less percentage. If you want more resilient, you need to have more resources left in the cluster. Yeah, I hope it answers your question. Next one. Around 20 cluster, is there a possibility to upgrade them in some automatic script by Ansible? Other scripts. So Ansible is a configuration management tool. You can use Ansible to run RTF command, but still, you need to make sure you go through all the checklists for the upgrade, so that upgrade can go smoothly. So Ansible here is only a tool to run the RTF command remotely. You can do that way. And for the troubleshooting part, you still need to, if it runs into the issue, you still need to log into server and troubleshooting on that cluster. Okay, next question. Hi, Rosen. I see some question has a thumbs up. This means it's answered yet
No,
already?
the ones that thumbs up are the ones that I have voted because they haven't been answered. So you're
Okay.
presenting the correct ones.
Okay. Do you have any tools, Macenta? Do you have any tools or utility to extract vehicle allocation? I think there's not such feature in the endpoint platform. If you want to see the vehicle allocation, the best way to do is use a kubectl command. You run kubectl describing nodes command. You will see how many CPUs and memory occupation on each node. In this way, you can see. In this way, you can see the CPU and memory resource for each application and for on each node. Okay, next one is from Mark Wilson. How often should the RTF customer run an upgrade? From experience, it's not good to be too back level. Yes, you're right. So the upgrade, if the gap is too big, then there will be more components involved in the upgrade process. And another thing I understand is there's some compliance or requirement don't want to upgrade frequently, and at this stage we release appliance almost once per month. It's pretty frequent. We still need to keep up with the pace and doing a lot of bug fixing. So in that case, I would recommend let's do it once per month is too frequent. But if you like do once or twice a year is too less. Have too much gap in the appliance version. You might run into issues because of the bugs in the old versions, and also in the future upgrade, there are too many components involved. It's likely to has high chance to run into issue. So my recommendation is we can do like in 2 months. In 2 months' time, do one upgrade. And now we release every month. So you mean you skip one and do it every 2 months, and we will reduce the frequency in future, and this is our agenda. So in that case, you can just schedule upgrade every quarterly upgrade. You probably release one variant every quarter. Is you just do a quarterly upgrade. So my recommendation for now is every 2 months, and in future probably just once per quarter. And if you have less appliance releases, just follow the pace with the appliance releases. We're aiming to use a quarterly release in the future. Okay. Does MuleSoft provide trial license to practice settings up to RTF classing Azure or AWS? Naga's question. I think you're asking about the Mule application applying license. The RTF, I'm not sure about Rosten. Do you need a license to run RTF cluster?
As far as I know, you do need a license to install the cluster. And the easiest way to get it is to, if you work in an organization that already has a license, then to use it that way. Unfortunately, if you don't work in an organization that has one, it can be a little bit challenging. I'm not aware of a way top of mind, but maybe Naga, you can explain your circumstances and see what option works best for you. But the short answer is yes, you need a license. And if you work in an organization, you might be able to ask for a trial, but it's a little more difficult if you're an individual by yourself. Right, Stephen, I think that covers all the questions in the Q&A that I had seen. Is that correct?
Not yet. I still got a couple questions here.
The rest of them, I've answered them already in the chat.
Oh, you answered them.
I've answered them in the chat.
Okay.
Already. And we're also a little past time, so maybe it's a good time to wrap up. So just to answer this question, the slides will be shared on the event page within 24 hours. and so will the recording. So if you've missed any of it, or if you had poor audio quality, you can catch up. Stephen, were there any final comments you had before I wrap up?
And no, thanks everyone for your time attending the session. I really appreciate your time, and I hope you enjoyed. And if you got some feedback, feel free to talk to Rustan. We probably can schedule more sessions around RTF this product. I'm look forward to see you in the future sessions. And thank you.
All right, and there is one more question in the chat. Sorry, in the Q&A, Stephen. Would you be open to answering that? On special request.
Last one?
Last one. The one at 109 by Siddhartha.
Siddhartha, okay. Present this one. Thanks, Siddhartha. Okay, your question is, I apologize asking a scoop question again. Could you answer below? Deployment is publish the Exchange. Is it possible to deploy without publishing to Exchange? And deploying is Artifactories. Yes, the current deploy process is push the artifacts to the Exchange. And we have seen the requirements about like push the artifacts to other repositories. But still, this is on the agenda to discussing, because many things to do to consider the security and also the impact to the deployment process. So for now, I think this is still a topic. This is still a requirement to be discussed, but I don't have agenda when it will be available in the future. Yeah.
Yep, I agree with that as well. I don't believe it's possible right now. Is the short answer for you, Siddhartha. All right, Stephen, a huge thank you for taking the time and effort to put this presentation together and to answer all the questions. Everyone, thank you for joining us at this meetup. Again, if you can submit feedback about what you thought worked well and what didn't work well, that would be fantastic. And also, if you'd like to thank Stephen, whether it be through the feedback or on LinkedIn, you may do that as well. Please stay tuned for announcements about upcoming meetups, and I hope you have a wonderful rest of the day. Thank you.
See you, everyone.